Hello students, welcome to CBSE's first personalized chapter model tuition. This is me Anjana, your physics tutor, and today we are going to discuss about different questions based on reflection of light from grade 10. So welcome to our classes. So let's see the exam special material based on reflection of light. So this is for grade 10 reflection of light. And this model questions assertion and reason. Assertion and reason type of questions are very common questions, right? These kind of questions are the most common kind of questions. So either we can choose the option like the assertion is true. Assertion is true, the reason is false, or both assertion and reason, both are true, and A is true and R is false. A is false, but R is true. Okay. So according to the different options, we can go through the question, just go through the assertion and reason given here. Okay. Question number 1. The center of curvature is not a part of the mirror. It lies outside its reflecting surface. Okay. So we already studied about the center of curvature. Okay. So it is not a part of the mirror, but it is a part of a sphere where this mirror is a part. And the reflecting surface of a spherical mirror forms a part of a sphere. And the sphere has a center. Okay, that is about the definition of the center of curvature. So here, both the assertion and the reason are true. And here, the reason is the correct explanation of A, okay, of the assertion. Question number 2. A ray passing through the center of curvature of a concave mirror after reflection is reflected back along the same path. We know that as per our rule number 3, we have, as a ray is traveling through the center of curvature, after reflection, it will travel back through the same point. Okay. What is the reason behind it? In that case, the angle of incidence is 0 because the incident ray is falling on the mirror. Okay, it is falling on the mirror along the normal. So because of that, here the assertion as well as the reason are true, and reason is a correct explanation of A. Okay, this is based on our rule number 3, which we are using to draw the ray diagrams. Okay. Question number 3. The mirrors used in searchlights. The mirrors which are used in searchlights, they are concave spherical. And the reason is, in concave spherical, the image formed is always virtual. Okay. In concave, is the image formed always virtual? No. Concave can produce real images as well as virtual images based on the position. Okay. So here the assertion is true and the reason is false. Question number 4. For observing traffic at the back, the driver's mirror is convex mirror. Okay. A convex mirror has much larger field of view than a plane mirror. Yeah, the answer is correct, right? So both assertion and reason are true, and reason is a correct explanation because the convex mirror is giving us a wider view. Okay. And question number 5. It's an important question. Mirror formula can be applied to a plane mirror. Okay. And a plane mirror is a spherical mirror of infinite focal length. Yes. Mirror formula 1 by f is equal to 1 by v plus 1 by f equal to 1 by v plus 1 by u. This can also be applied to a plane mirror because plane mirror is a spherical mirror of infinite focal length. Okay. So here both the assertion and reason are true and reason is the correct explanation of the assertion. Okay. Question number 6. The height of an object is always considered positive. As per the new Cartesian sign convention, height of an object, it is always in the positive y-axis, right? It is always in the positive y-axis and it is always upright. The height of an object, HO, is always positive because it is upright as well as it is in the positive y-axis. Okay. And here, what is the reason given? An object is always placed above the principal axis in upward direction. Okay, here, this is the principal axis and it is placed above that principal axis and the position is upright or erect. So here also, the assertion and reason are true and reason is the correct explanation of A. Okay. So when you get a question like this, you have to go through both the assertions and reasons. Okay. Then only we can conclude about the answer. Concave mirrors are used as makeup mirrors. Yes. Okay. But what is the reason given? When the face is held within the focus of a concave mirror, then a diminished image of the face is seen in the concave mirror. Is that the reason? When you keep an object within the focus. What is within the focus? Between pole and focus. That is within the focus. In a concave mirror, it is forming a virtually erect and enlarged image, not a diminished image. Okay. So here the reason is false, but assertion is true. Question number 8. A person cannot see his image in a concave mirror unless he is standing beyond the center of curvature of the mirror. Is that true? Okay. It's not true. In a concave mirror, the image formed is real provided the object is situated beyond its focus. Reason is true, but the assertion is false. Okay. Because for different positions in a concave mirror, we can see the images. Okay. It can produce image of same size, diminished, as well as it can produce image of like enlarged image also. Okay. So it can produce real images for all 5 positions except the image, the object is within the focus. Okay. And question number 9, the virtual images are always erect. Okay, virtual, the combination is erect. Okay, virtual images are always erect. Assertion is true. Now let's see the reason. Virtual images are formed by diverging lenses only. Is that correct? No, it's not true. The reason is false, but assertion is true. Question number 10. The magnification of a real image is negative, whereas the magnification of the virtual image is positive. Real images always inverted and virtual images are erect. So magnification is negative for the real images, positive for the virtual images. Okay. So here both the assertion and reason are true and the reason is the correct explanation of the assertion. Okay. And next is MCQ question, multiple choice. We can select answers from this, from the choices given. Okay. In order to obtain a magnification of minus 6 magnification in a concave mirror. Okay. So it is a real image. The object must be placed at the focus, between the pole and focus, virtual image. Here, at the focus, enlarged image. Then, beyond the center of curvature, between the focus and center of curvature. So, to get a negative magnification, the image should be real. Okay, the image should be real. That case is okay except this one. Except point B, all other cases are forming real images. So we will get inverted one. But 0.6 is less than 1. Okay. 0.6 is less than 1, which means the image is diminished. So in which case we are getting the diminished image, That is beyond the center of curvature. When you keep an object beyond the center of curvature, we are getting a diminished image. Okay. So the choice is beyond the center of curvature. Then image formation in a plane mirror. The characteristics of the image formed in a plane mirror. We know that the image formed in a plane mirror is virtual erect, as well as distance of the image to distance of the object is same. Height of the image is equal to height of the object, or the size of the image is equal to size of the object. Laterally inverted. Laterally inverted. Okay. Inverted. So these are different points. So image formed by a plane mirror is virtual and erect. Okay. Virtual erect images are formed by a plane mirror. An object is placed at 100 mm in front of a concave mirror, which produces an upright. Upright means erect image. So what is the condition, first of all? Concave mirror, upright image. We have to keep the object between the pole and the focus. Okay. We have to keep the object between the pole and the focus. So in this case, object is placed at 100 mm in front of a concave mirror. The object is placed 100 mm in front of a concave mirror. So concave mirror somewhere here. Okay, 100 mm. And so the focus will be somewhere after this 100. Okay. We know that the object should be placed between 0 to F, or the pole to F, between pole and F, the focal length. Okay. And radius of curvature. We know that the relation between the radius of curvature and focal length is R is equal to 2 times the focal length. Okay. But here we doesn't know the focal length, but we know that this distance 100 is given. Okay. So anyway, our focal length will be greater than 100. Okay. So let's see. 2 times 100 is 200. Our focal length is anyways, it is slightly, it will be greater than the 100. So the radius of curvature should be also greater than 200. Okay. Because of this relation, R is equal to 2F. Okay. Because of the relation R is equal to 2F, we will get that this R should be greater than 200 mm, because an erect image is produced in a concave mirror if and if only it is placed between the pole and the focus. Okay. These model questions are very, very important. Okay, case 6, in a concave mirror. A concave mirror which is producing virtual erect image when it is placed between the pole and focus is very, very important. Which position of the object will produce a magnified virtual image if a concave mirror of focal length 15 centimeter is being used? Again, same case, object is placed between the pole and the focus. Okay. Focal length is 15. So the range of distance will be between, it will be between 0 to 15, right? It will be between 0 and 15. Okay. So let's see which number is between 0 and 50. Option A, 10. 10 lies between 0 and 50. Okay. Option 2, 20 greater than 15. No. 30 greater than. 35 also greater than. So the answer is 10 centimeter. Okay. Because 10 centimeter lies between 0 to 15 centimeter. To get a virtual image, we had to keep the object in a concave mirror between the pole and focus. If focal length is 15, the range of distance is between 0 and 15. Here it is 10 centimeter. Okay. Very, very important type of question. Which of the given is not paired correctly? Okay. Some uses are given. Solar furnace is for a concave mirror. Rear view mirror is a convex mirror. Magnifying glass is a convex lens. And none of this is paired correctly. Is not paired correctly. All these are correct. Okay. So the answer is none of these. And two big mirrors are fitted side by side on a wall. A man is standing at such a distance from the wall that he can see the erect image of his face in both mirrors. Erect image is formed in both mirrors. When the man starts walking towards the mirror, he finds that the size of his face in mirror A goes on increasing. Okay. So which means the position is changing and there is difference in the size. Okay. But mirror B is same. Mirror B is same. Okay. And its erect image of his face is there. And when he starts walking towards the mirror, he find that size of his face is increasing. Okay. So what is which one is mirror A? Which kind of mirror is A? Which kind of mirror is B? We know that the one and only mirror which is changing the size as per the type of position is concave one. Okay. And B remains the same, which indicates that it is a plane mirror. There is no change in the size. Okay. The position is changing, but there is no change in the size. Okay. So option A, concave, convex. Option B, plane plane mirror and concave. Option C, mirror A is concave and mirror B is plane. And option D, mirror A is convex and mirror B is concave. But we know that the first one is changing the size as per the position. It should be concave. And the second one is not changing the size as per the position. So it is a plane mirror. Okay. So go through all options. Okay, before choosing the answer, go through all options. Magnification produced by a rear view mirror fitted in vehicles. We know that rear view mirrors are only used in convex, right? We are using convex mirrors for the rear view purpose. And convex mirror only produces virtual, erect and diminished images, right? They're only producing virtual, erect and diminished images. Diminished, in that cases, magnification will be less than 1 because height of image will be less than the height of object. Okay. And magnification is given by the relation magnification is equal to height of image over height of object. Okay. So if magnification is less than 1, the height of image will be less than the height of object. We know that rear view mirrors produce only diminished images. So in that case, magnification will be less than 1. Okay. Okay. Rays from sun converge at a point 15 centimeter in front of a concave mirror. Okay. Where an object should be placed so that size of the image is equal to size of the object. So what is it condition in a concave mirror where we are getting equal size for the image as that of the object? Object at C. We have to keep the object at C. When I keep an object at C in a concave mirror, height of the image will be equal to height of the object. Okay. Distance of the image from the mirror will be equal to distance of the object from the mirror. Distance of the object from the mirror equal to distance of the image from the mirror. This is a condition where when you keep an object at C in a concave mirror. Okay. So here the question is, where should an object be placed so that the size of the image equal to size of the object? This condition is object at C. But here, what is given? 15 centimeter. It is converging at a point 15 centimeter in front of a concave mirror. What is that? This is the focal length. 15 centimeter is the focal length. F is equal to 15 centimeter. And we know that the relation R is equal to 2F. 2 into 15, 30 centimeter. Okay. So we have to keep the object 30 centimeter in front of the mirror. We have to keep the object at 13 centimeter in front of the mirror. Okay. The image which is formed behind the mirror is called as, yes, from the definition itself, we know that it is a virtual image. It cannot be projected on a screen. Only real images can be projected on a screen. A virtual image is an image formed by light rays that appear to diverge from a point behind the mirror. Okay. So they will not be, we cannot project it on a screen. Okay. So it is from behind the mirror. That is a virtual image. Sorry. A child is standing in front of a magic mirror. She finds that the image of her head is bigger, middle portion is same size, legs are smaller. Okay, head is bigger, middle portion is same size, legs are smaller. Okay, which kind of mirror is giving us a magnified one view? Only a concave one can produce a magnified view when it is placed at certain position. Okay. And so we can find that, we can just conclude that head is bigger means that part is made up of a concave mirror. Okay. First part is a concave mirror. Head is concave. Okay. And the middle portion is same size. Which kind of mirror is giving an image of same size? That is a plane mirror. Okay. Plane mirror is giving same size. That is a body part is a plane mirror. And legs are smaller. Diminished image. A convex. Okay. A convex one is given for the legs. That's why it is getting a diminished image. So, concave, plane, convex. That is the order. Concave, plane, and convex. A lens and a spherical mirror both have focal length of minus 15 as per the sign convention. Minus 15 for a lens as well as a mirror. Then it may be concluded that both are concave. Both are concave, no doubt. Okay. An object of height 4 centimeter is kept at a distance of 30 centimeter from a pole of a diverging mirror. Which is a diverging mirror? It is a convex mirror. Diverging. It's a convex mirror. If the focal length is 10 centimeter, what is the height of the image formed? Okay, we have to find the height of the image formed. So let's see which all parameters are given here. The height of the object is 4 centimeter. And what is U? U is always negative. U is minus 30 centimeter. Focal length, convex mirror, diverging mirror is positive. So it is positive 10. Apply the mirror formula. 1 by F is equal to 1 by V plus 1 by U. 1 by F equal to 1 by V plus 1 by U. 1 by 10 is equal to 1 by V plus minus 1 by 30 or 1 by minus 30. And let's take the 1 by V in one side and the other numbers in the right hand side. Okay. So 1 by V is equal to 1 by 10 plus 1 by 30. Just cross multiply it. 30 plus 10 over 30 into 10. Then from that, take the reverse. This is like 40 by 300. Okay. That is 1 by V. To get V, we have to take the reciprocal. 300 by 40. In that case, we will get 7.5. Okay, we will get 7.5. But what is our question? Our question is, find the height of the image formed. How can we find the height of the image? We have V. Now we have V value, U value, F value, and height of the object. But we don't have the height of the image. So what to do? Equate the two different formulas for magnification. Magnification is given by negative V over U is equal to HI over HO. Two different relations are there. Okay, we are just giving the values for V and U to find the magnification. Okay, so magnification is minus V by U. Minus V is minus 7.5 divided by the U value is negative 30 given in the question. When you divide it, you will get the answer 0.25. There is no unit for magnification because magnification is a unitless quantity. Okay. And if you have magnification, how to find the height of image? Magnification is given by height of image by height of object. So how to get the value of height of image? Height of image is equal to magnification into height of object. Magnification into height of object. So it is 0.25. Magnification into height of object is 4. So height of image is 1 centimeter from that. Let's see the options. Options 3 centimeter, 2.5 centimeter, 1 centimeter, and 0.75 centimeters. So the answer is 1 centimeter. Apply the mirror formula. After that, equate the two different formulas for magnification. Okay. First of all, we have to analyze that the kind of mirror is convex because it is diverging. Focal length for a convex mirror is positive. If you take negative 10, your answer will be wrong. And which of the following statement is not true in reference to the diagram shown below? Okay, just analyze the diagram. It's a concave mirror. Object is placed at C and image is formed at C. Images of same size. Okay. And let's see the options. Image formed is real. Okay, correct, right? Image formed is enlarged. Is it? No, the image formed is of same size. Then, image formed at a distance equal to double the focal length. Hence, image is formed at C. And what is the relation? 2F. R is equal to 2F. So this is also correct. Image formed is inverted. Yes, the image is inverted. Okay. So what is the wrong option? Image formed is enlarged. No, the image formed is of same size as that of the object. Radius of curvature of a converging mirror is 30 centimeter. Converging mirror, concave. Radius is 30 centimeter. At what distance from the mirror should an object be placed so as to obtain a virtual image? Okay. Radius of curvature is 30. From that, we can find the focal length. How to find the focal length? If radius of curvature is 30, focal length is R over 2. 30 over 2 is 15 centimeter is the focal length. Then we need to get a virtual image. At what position will we get the virtual image? We have to keep the object between focus and the pole in a concave mirror. Okay. Pole is taken as the origin 0. So here the focal length is 15 centimeter. So what is the range of the distance? The distance should be between 0 to 15 centimeter. Okay. Between 0 and 15 centimeter. That is the correct option. Between 0 and 15 centimeter. And this question is connecting with the new Cartesian sign convention. Very simple question. It's a question from 2022 board exam question paper. For the diagram shown, according to the new Cartesian sign convention, the magnification of the image formed will have the following specifications. Okay. We know that this is the case 6 in a concave mirror where the object is placed between the pole and focus. So we are going to get a virtual image which is erect, enlarged. Okay. And let's see the magnification. Magnification sign and the value. As we know that it is a virtual, erect, enlarged image. Okay. It's going to form virtual erect enlarged image as it is placed between the P and F in a concave mirror. Virtual erect and enlarged image is going to form in this. And we know that enlarged image, which means magnification value greater than 1. Erect or upright image, magnification is positive. Okay. So let's see the options. Magnification sign is positive, value less than 1. No. Sign is positive, value more than 1. Right. Okay. Sign negative. No. Sign negative. No. Magnification sign for erect images is positive. Okay. And that value is greater than 1 since it is enlarged. Okay. Okay. Next, let's see some questions. Answer the following questions. And this question is from 2024 paper. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Okay. An object is placed at a distance of 10 centimeter from a convex mirror of focal length 15 centimeter. Find the position. What do you mean by position? We have to find the value of V. V means the position, right? Position is given by V. Okay. Position is given by V. So what all things are given in the question? From the question itself, we can see that focal length is plus 15. Distance of the object from the mirror U is minus 10. Okay. Let's apply the mirror formula 1 by F equal to 1 by V plus 1 by U. 1 by 15 equal to 1 by V plus 1 by minus 10. Rearrange the equation. So 1 by V is taken to the left hand side. So 1 by 15 plus 1. Otherwise, you can do one more step. 1 by 15 equals, sorry, 1 by 15 plus 1 by 10 is equal to 1 by V. Okay. Next step is 1 by V equal to 1 by 15 plus 1 by 10. So cross multiply 10 plus 15 over 10 into 15. Okay. That is 25 over 150. Okay. This 25 over 150 is the value for 1 by V. Where is V? Take the reciprocal, 150 by 25, that is 6 centimeter. So, where is the position? Position is 6 centimeter behind the mirror. Okay, it's a virtual image because it's a convex mirror. It's a convex mirror, it is forming a virtual image. Okay, next is source-based or case-based questions. We can see repeated questions from like these kind of questions are repeated. 2024 and 2025, they got same kind of question. Okay. So a data table is given. From there, we have to analyze and we have to answer the questions based on that data. Okay. So let's see the table. Mirror A is given. It is having a focal length 20, but the distance of the object is at 45. Okay. And mirror B, focal length is 15. Distance of the object U. Object distance is U. Okay. That is 30. And third case, focal length is 30. Object distance is 20. Okay. If you have the focal length, how to find the value of R? R equal to 2F. So for mirror, 20 is focal length. R will be 20 into 2, 40. And for mirror B, 15 into 2, 30. R or C. Okay, let's see. C. 30, 30 into 2, it's 60. So let's analyze where is object placed in each case. Here, mirror A, object distance is 45. Okay, which means it is beyond C. Can you see? Center of curvature is 40, but U is 45 means it is beyond C. Next case, U is 30 and C is also 30, which means object is at C. When you keep an object at C, the image size will be same as the size of the object. And next case, focal length is 30 and C is 60, but the object is placed at 20, which means the object is placed between the pole and focus. A virtual enlarged erect image is going to form in that case. Okay, this is how we can analyze the table, and let's see the questions. Okay. In which of the above cases the mirror is going to form diminished image? Justify your answer. Okay. So this is the case. First find the value for C. We already found the value for C. And in A, for a concave mirror, a diminished image is formed when you keep the object at infinity or beyond the center of curvature. Okay, so our mirror A, that case is beyond C case. Okay, so it is going to form a diminished image. Okay, And mirror B, what is the condition? Mirror B, the object is placed at C. It is going to form an image of same size as that of the object. Mirror C, object is placed between the pole and focus. A virtually erect and magnified or enlarged image will be formed. Okay. So diminished image is mirror A. Question 2. What are the two different properties of image formed in case 2? Case 2, object at C. Okay, the object is placed at C. Real inverted. Same size, as well as the image is formed in same size as that the object is kept. And size is also same. Real image is formed inverted. Real inverted and same sized image is formed when you keep an object at C. So question 2 option, that question 2, the answer is real inverted, same size. And question 3 or option 3 in this, 3A. What is the nature and size of image formed by mirror C? What is the nature and the size of image formed by mirror C? And we know that in that case, the object is placed between P and F, right? Object is placed between P and F. When you keep an object between P and F, the image formed will be virtual, erect, enlarged. Okay. It is going to form virtual, erect, enlarged image. Okay. Draw a ray diagram to justify that. Students, this question is very, very important. Okay. The image formation when you keep an object between the pole and focus is very, very important. Okay. So in that one, we are just drawing the mirror, draw the principal axis, mark the focus and the center of curvature. And first ray, the object is placed between the pole and the focus. Object is placed between the pole and the focus. And first ray, after reflection, it will travel through the principal focus. And second ray is traveling through C. Rule number 3, it will travel along C only. So after the reflection, it will travel along C only. So, but what happened? These two rays are meeting behind the mirror and forming virtual, erect and magnified image. Okay, this is the case when you place an object between the pole and the focus. Very, very important case. It's very, very important. Okay, it's very, very important case. Let's see what is 3B. There is a or question. Okay. So either you can do, if you get a question like this, either you can choose 3A or you can do 3B. An object is placed at a distance of 18 centimeter from the pole of a concave mirror of focal length 12. Find the position. You have to find the value of V, but the focal length is given. Distance of the object from the mirror, that is U. Both U and F is given. Find V. Simple question. Okay. Students, one more method is there to form image, that virtual image when you keep an object between P and F. Okay. If you know the first method, no need to study the second method. If you know the second method, no need to study the first method. In this method, here the object, first the ray is traveling after reflection. The incident ray is hitting the pole obliquely. It is reflected back obliquely. Okay. And the second ray, it is traveling through the center of curvature only. But these two rays are meeting behind the mirror and it is also forming a virtual, erect, enlarged image. Okay. Any one method is enough. But don't forget to study the ray diagram for the image formation when you keep an object between the pole and the focus. Okay, any one diagram is enough. I think this one is better and this one is common in most of the textbooks. Okay. And our option 2, what is given? The focal length, and it is a concave mirror, right? It's a concave one. It's a concave mirror. Focal length is -12, it is given, and U. What is U? The distance of the object from the mirror is -18. It is given in the question. So how to do? Take the mirror formula. 1 by F equal to 1 by V plus 1 by U. Substitute. 1 by -12 equal to 1 by V plus 1 by -18. Okay. So again, take 1 by V to left hand side and the fractions on the right hand side. 1 by -12 plus 1 by 18 is equal to 1 by 18 minus 1 by 12. Cross multiply. Okay. Then after cross multiplication, we will get it as 12 minus 18 over 12 into 18. How to find V? Take the reciprocal of this one. 12 into 18 over 12 minus 18. 216 over minus 6, and you will get the answer as -36. Okay. Okay. Define the following terms in the context of diverging mirror, convex mirror. Okay. Diverging mirror. So what is principal focus? Principal focus is a point on the principal axis where the rays incident parallel to principal axis appear to diverge after reflection. Okay. Because they are asking only about the principal focus and focal length of a convex mirror, diverging mirror. Okay. So what is focal length? It is a distance between the pole and the principal focus. The pole and the principal focus. That distance is called as focal length. Okay. Hold a concave mirror in your hand and direct its reflecting surface towards the sun. Direct the light reflected by the mirror onto a white cardboard held close to the mirror. Move the cardboard back and forth gradually until you find a bright, sharp spot of light on the board. The spot of light is the image of the sun on the sheet of paper, which is also termed as the principal focus of the concave mirror. Okay. Don't get afraid after seeing this kind of paragraph. Okay. The questions will be very easy. See, the image formation diagram is also given. List two applications of concave mirror. After reading this paragraph, I am sure that 50% of the students will get confused after reading this paragraph. But let's see the options, the subpart. List two applications of concave mirror. Very, very simple question. Concave mirror, makeup mirrors. Dentist is using it as their head mirrors. ENT doctors, dentist, all those doctors are using it as their head mirrors. Shaving mirrors. Okay. You can list any two applications. If the distance between the mirror and the principal focus is 15 centimeter, find the radius of curvature. So what is 15 centimeter? It is given that the focal length is 15 centimeter. The distance from the pole to that focus. Okay. So how to find the question is find the radius of curvature. How to find the radius of curvature? How to find the radius of curvature? It was 2 into focal length. 2 into 15. 30 centimeter. Very simple, right? So when you get a question, read the question 2 times. Okay. Sometimes the answer will be very easy. Draw a ray diagram. Repeated question. Draw a ray diagram to show the type of image formed when an object is placed between the pole and focus of a concave mirror. Okay. It is placed between the pole and focus. Same question. You can draw any one method. Okay. You can draw any one method about the ray diagram formation when you keep an object between the pole and focus. Okay. Then question D. An object 10 centimeter in size is placed at 100 centimeter in front of a concave mirror. An object 10 centimeters. So the height of the object is 10. And it is placed at 100 centimeter in front of a concave mirror. What do you mean by that? It is a distance u equal to negative 100 centimeter. If its image, this is u, if its image is formed at the same point, image is formed at the same point. Okay, this is the question. Very, very interesting question. But the answer is very simple. Image is formed at same point and it is a concave mirror. So what is the condition? It should be kept at C. Okay. To get an object, sorry, to get an image of same size or at same location, the object should be kept at C. The object should be kept at C. If U is equal to negative 100, V is also negative 100. Okay. If U is equal to negative 100, V is also negative 100. Okay. How to find the focal length? That is the question. And we know that mirror formula 1 by f equal to 1 by v plus 1 by u. U was given in the question minus 100 centimeter. Okay. As object is placed at C, image is also formed at C only. Image is also formed at C. Okay. U is equal to v in this case. If u is minus 100, v will be also minus 100. So substitute here 1 by f equal to 1 by minus 100 plus 1 by minus 100. That is minus 2 by 100. That is 1 by f. So what will be f? F will be minus 100 by 2. That is negative 50 centimeter. Okay. Negative 50 centimeter. So focal length is 50 centimeter. Negative indicates that it is a concave mirror and the image produced is real, inverted. Okay. Question 2 from that. So here we found the focal length. Magnification of the image formed with sign as per the new Cartesian sign convention. We know that height of the image will be equal to height of the object in that case, but the height of the image is inverted. Okay. And u is equal to v. Let's substitute in the magnification formula. Magnification is equal to minus v divided by u. Okay. Magnification is given by minus v divided by u. So magnification is minus v by u. 1 second. Not this one, sorry. So here the magnification is minus v by u. And we know that u is minus 100, v is also minus 100. So it will be like so magnification is equal by minus v by u and equal to minus 100 divided by minus 100. There is no 1 by half here, sorry. Minus 100 over minus 100. Minus, it will be plus 100 and denominator is again minus 100. So the answer is minus 1. Okay. So the answer is minus 1. minus 100 over minus 100. Okay. Otherwise, you can keep the minus in the formula there. Minus 100 by minus 100. That 2 minus can also be cancelled out. Anyways, the last answer will be negative 1. The last answer is negative 1. When you keep an object at C, the magnification will be negative 1. Okay. When you keep an object at C, the magnification will be negative 1. What are points we need to know? When you keep an object at C, height of image will be same as height of object, but there will be a negative sign. Why? The image is inverted and location of the position of the image formed will be equal to the position of the object kept. Okay. That is the case when you keep an object at C. Okay. If you want to obtain a virtual and magnified image of an object by using a concave mirror of focal length 18. We want to get virtual magnified image using a concave mirror. What is the condition? We have to keep the object between P and F. Focal length is 18. Concave mirror. Where should the object be placed? Use the mirror formula to determine the object distance for an image of magnification +2 produced by this mirror to justify your answer. Okay. So we want to get a virtual image. So what is the condition? It should be placed between P and F. Okay. And mirror formula 1 by F equal to 1 by V plus 1 by U, and magnification equation is negative V by U. And here the magnification is given as +2, right? It is given +2. Okay. And what all values are given? Focal length is given as negative 18. Focal length is negative 18. Focal length is negative 18. Okay. So we have focal length, but we don't have the values for V and U, but we have magnification as +2. Okay. We know that magnification is given by negative V over U. From this, form a mathematical relation between the V and U, so that we can write that V is equal to -2U. Minus V by U is +2. V equal to -2U. Otherwise, V equal to 2U. So, -2U. Clear? Okay. Substitute. Okay. Using this, instead of V, we can substitute -2U. 1 by F equal to 1 by V plus 1 by U. 1 by F. Instead of F, we can substitute -18. 1 by -18 is equal to 1 by U. Okay. 1 by U plus 1 by V, or 1 by V plus 1 by U. Instead of V, substitute -2U. -2U plus 1 by U. 1 by U is as such 1 by. So this can be also written as 1 by U minus 1 by 2U. Now cross multiply. 2U minus U, 2U minus U divided by 2U into U. 2U minus U divided by 2U into U. Okay. 2U minus U is 1U. Okay, 1U. Divided by 2U into U is 2U squared. But I'm just keeping it like this. Then we can easily cancel it out. So this U and this U will be cancelled out. So the answer is 1 by 2U. Okay. 1 by 2U. The answer is 1 by 2U. What? 1 by -18 is? 1 by -18 is 1 by 2U now. Which means that -18 is 2U. How much is the value of U? U is equal to -18 by 2, which is -9 centimeters. Okay. U is -9 centimeter. So from that, how to find V? We know that V is equal to -2 into U. V is -2 into -9. That is +8, because why it is +8? It is a virtual image. It is a virtual image as it is kept between the pole and focus. As it is kept between the pole and focus, the image is virtual. Okay, and erect. Virtual and erect image is formed. Okay. So this is the question here. Magnification was given. Focal length is given, and only one hint is given. The magnification is +2, and it is a concave mirror. To get a positive magnification in a concave mirror, the object should be kept between the pole and focus. The object should be kept between the pole and focus. And to apply in mirror formula, we doesn't have the values of this V and U. We don't have the values of V and U. So what should we do? Instead of that, find a statement or a relation for this V and U from the magnification formula. Magnification is equal to minus V by U is positive 2. So minus V equal to 2U. So V is equal to negative 2U. And substitute this instead of V in our mirror formula. Okay, just substitute. After that, we will get that 1 by negative 18. Focal length is negative 18. 1 by negative 18 is 1 by 2U. Negative 18 is equal to 2U. So what is the value of U? It is negative 9. So if we have the value of U, how to find V? V is equal to negative 2U. Negative 2 into negative 9 is 18 centimeter plus, because it's a virtual image. A spherical mirror produces an image of magnification negative 1 on a screen placed at a distance of 50 centimeter from the mirror. This question is repeated board exam question. 14, 16, 18, 20. Okay. Magnification negative 1. Who is producing the magnification negative 1? Which kind of mirror is producing a magnification of negative 1? Okay. A concave mirror, when object is placed at C, image is also formed at C, but the image formed is inverted. Only in that case, we will get a magnification of negative 1 at C. Okay, object at C in a concave mirror. Let's say concave mirror. Okay. What type of mirror is it? You know that it's a concave mirror. Negative magnification, MS negative. MS negative means it is a real image, inverted image. Okay. Real inverted image, and here the size is same. So, what kind of image is that? The image is real inverted and same size when you keep an object at C in a concave mirror. So, it is a concave mirror. And what is the nature of the image formed? It is real, inverted, same size. Okay, it's a concave mirror. And how far the object is located from the mirror. Is there any hint? Here, what is given? A spherical mirror produces an image of magnification negative 1 on a screen. Screen, real image. Again, there is a hint for the B part, nature. Negative, inverted. Screen, real. Or the combination of inverted is always real. And placed at a distance of 50 centimeter from the mirror. Okay. So what is given as 50? V is negative 50, right? V is negative 50. How much is U? Actually, from the theory portion, we know that U will be also 50, negative 50. Because it is object, when you keep an object at C, position, the location of the image as well as object will be same. It is in the left hand side. If V is negative 50, U will be also negative 50. Okay. Either you can write like that, otherwise we can just substitute in the magnification formula. M equal to negative V by U is negative 1. It is given in the question. Okay. We have the value for V. V is negative 50. Minus of 50 divided by U is minus 1. Okay. Magnification is minus 1. Just rearrange it. We will get that U is also negative 50. Okay. Otherwise, we can write that when you keep an object at C, we will get image at C only. Okay. So the distance of the object from the mirror is equal to distance of the image from the mirror. Otherwise, you can just show a ray diagram also. Okay. But this method is also correct. Okay. Ray diagram. How to draw a ray diagram? Keep the object at C. Image is also formed at C. Okay. Image formed is real, inverted, and same size. So here, the focal length is marked, focus is marked, the pole is marked, and 2F. What is 2F? It is a C. Okay, C is marked. What happened? The object is kept at C. First ray, traveling parallel to principal axis. After reflection, it will travel through the focus. It will travel through the focus. Second ray, traveling through the focus. After reflection, it will travel back through the, it will travel back parallel to principal axis. And these two rays are meeting at C. Okay, these two rays are meeting at C. This is the image formation when you keep an object at C. Okay. A student wants to obtain an erect image of an object using a concave mirror of 10 centimeter focal length. Okay. What will be the distance of the object from the mirror? What will be the distance of the object from the mirror? 2015, 19, 23. Okay. So, focal length 10 centimeter. Focal length is 10 centimeter. It's a concave mirror, so it is negative 10 centimeter. Okay. And erect image using a concave mirror. To get an erect virtual image, enlarged image, object should be placed between the pole and focus. Okay. Should be between the pole and focus. Pole is taken as the origin 0. Here the focal length is 10 centimeter. So where should be the object kept? The object should be between 0 and 10. You can write like that. Okay. We have to keep the object between 0 and 10. Or you can write that object can be placed at a distance less than 10 centimeter from the mirror towards left. The image formed by a spherical mirror is real, inverted, and is of magnification -2. The image formed by a spherical mirror is real, inverted, and magnification -2. If the image is at a distance of 30 centimeter from the mirror, image is at a distance of 30 centimeter. Let's say spherical mirror, real, inverted. Real image is only formed from a concave mirror. Okay, so V is taken as -30. Where is object placed? U is question mark. Magnification is -2. It is given. Magnification is -2. Value of V is given. How to find the value of U? And if you have magnification minus V over U, U will be minus V by M. Minus 30 divided by magnification -2. Cancel 2 minus, but still one minus is there. So that is 30 by 2 and minus is there. So it is -15 centimeter. Okay. That is the object, please. Find the focal length. We have V, we have U. So simply we can use the mirror formula to find the focal length. List the characteristics of the image formed if the object is moved 10 centimeter towards the mirror. Okay. Let's see the focal length. Then we will decide what will happen when we move this object. How to find the focal length? 1 by f is equal to 1 by v plus 1 by u. So 1 by f, f is missing. 1 by f equal to 1 by v. -30 plus u, 1 by -15. Okay, taking the negative outside. For simplification, you can use any method for simplification. No issues. Okay. 15 plus 30 by 30 into 15. But minus is the, don't forget to keep the minus here. So focal length is 30 into 15 by 30 plus 15 and a minus is there. Okay, this is like -45 over 450. So how to find the value of f? Take the reciprocal. -450 by 45, which is -10 centimeter. But list two characteristics of the image formed if the object is moved 10 centimeter towards the mirror. Where is the object location? It is 15, right? Okay. Focal length, we got the focal length as 10. Okay. At 10, this is the focal length, F. So C is 20. If F is 10, C will be 20. Where is the object placed? Object is placed at 15. Object is placed 15. Okay, between this. Object is placed here And the question is, list two characteristics of the image formed if the object is moved 10 centimeter towards the mirror. We have to think that. From this 15, 10 centimeter towards the mirror means 15 till here. Again, take 10 from here. Where is that location? At 5. Okay. From 15, take 10 towards right. The location will be 5. Okay. Where is 5? What is 5 means? See, the focal length is 10. 5 means it is between the pole and the focus. It is between the pole and the focus. When you keep an object between pole and focus, the image formed will be virtual, erect, enlarged. Okay. So here, see the question. Our object is placed at 15 centimeter. Negative 50 means this left hand side. Okay. And when you move it 10 centimeter towards the mirror, mirror is here. From 15, when you move 10 centimeter towards the mirror, 15 minus 10, the location will be 5. U is equal to negative 5, which means it is between the pole and focus because our focal length is negative 10. It is between the pole and focus. When you keep an object between pole and focus, it will form virtual, erect, and enlarged image. Okay. Okay. State the laws of reflection of light. Okay, this is also important. 2009, 12, 15, 18, 21. Okay, so the two laws of reflection of light, the incident ray, the reflected ray, and the normal to the surface at the point of incidence lie in same plane. Then angle of incidence is equal to angle of reflection. For example, if this angle is, for example, if this is 10 degree angle of reflection, angle of incidence will be also equal to 10 degree. Okay. As per the laws of reflection. So our last question, what is the angle of incidence and angle of reflection of a ray if the reflected ray is at an angle of 90 degree to the incident ray? The reflected ray is at an angle of 90 degree to the incident ray. Immediately we have to form a statement that angle of incidence plus angle of reflection is 90 degree in this case. Okay. As per the laws of reflection, we know that angle of incidence is equal to angle of reflection. So instead of R, we can write I. Angle I plus, again, instead of R, we can write angle I is 90 degree. Which means 2 into angle I is 90 degree. From there, it's easy to find angle I. Angle I is 90 divided by 2, which is 45 degree. If angle I is 45, angle I will be also equal to, angle R will be also equal to 45 degree as per the law of reflection. That's it. Okay. But the only thing is we have to form a statement like this. Angle I plus angle R is 90 degree. Okay. So students, this is it. And from this, we can analyze that the most important model question is coming from case 6 in a concave mirror. When you keep an object between the pole and focus, what is happening? That is the most important question. Okay. And everything based the ray diagram that like what kind of the characteristics of the image formed or the different kind of position, everything is important. Okay. Then when you keep an object at C, when you keep an object at C in a concave mirror, what is happening? We are getting image of same size as that of the object. The image is real and inverted. In that case, what will be magnification? Magnification will be -1. In that case, height of object is same as height of image, but height of image, we have to mark a negative due to that inversion of the image. Okay. And in that case, U and V will be equal. You have to memorize that. All ray diagrams are very, very important, but these two cases are the most important one. Okay. So that's it. Thank you so much. So thank you so much. Take care and bye.